Welcome to Breadboarding. Just over 2 years ago I started this channel to look at building digital electronics projects using solderless breadboards such as this one. You can see here this is an Intel 8088 microprocessor from around 1983. Now around November last year I started actually to build a PC on solderless breadboards, and in this video I'll just give you a quick summary of where we've got to over the last 9 months or so. So here's the Breadboard PC. It does look a bit of a mess, but believe me, it is relatively well organised and structured. All of these ribbon cables here, these are all known as DuPont cables, and a lot of them we've replaced the individual connectors on the end with sort of these shells here so that you can actually plug in multiple pins all at the same time. Normally put an 8-way shell on here. And that makes a lot of these cables a lot easier to plug in and maintain and manage, because occasionally you used to get the odd little one would pull out and it would cause sort of problems. Let's take a quick look at it. So we've got our Intel 8088 processor down here. So this is a 16-bit processor, but it talks to the outside world over an 8-bit data bus. Then we've got various clock circuits here, lots of buffers to buffer the outputs and inputs here to the rest of the computer. We've got the EPROM, the read-only memory, so this has the BIOS, the basic input-output system. So this is the software that starts up the computer and actually tries to look to find an operating system to start up. We've got 512K of memory here, so this is like half a megabyte of memory. Then down the bottom here, not quite got enough, the camera's not quite high enough to be able to see all of it, but down here, this is some of the very early boards are built. So this is actually an interface to a keypad and LED display. If you watch the summary video in the link at the end of this, there's about a 35-minute video, and I explain the background to the original 8-bit Motorola 6809 project where this came from. And when I first built the Breadboard PC, I used the keypad and LED display to be able to do some basic sort of debugging and things until I was able to get the full BIOS up and running. So down here we've also got a small serial port as well, so that allowed us to download software into the early stages of the nanocomp. At the top here we've got the direct memory access controller, and I'll talk at more length in another video about that, but that caused a lot of trouble trying to get the floppy disk controller working. Then we've got various interrupt controllers, timer, and the power on self-test port is a very simple port here, and that's connected to this logic analyzer. And the power on self-test port is a very simple latch really there that the BIOS and other software can just write messages or write byte values to that port, and we can actually check to see the status. So if things aren't booting, you might actually be able to see how far it's got to using that. Then over here, this is a video controller. The connector over here, there's a 15-pin VGA connector over here, and this is a monochrome display adapter compatible video controller. We've got a 4K dual port RAM down here, so that simplifies the interfacing. It's using a Motorola 6845 compatible video controller, and some of the things I did change on this is now actually outputting VGA compatible output rather than the original legacy monochrome and CGA output, just because I don't have any monitors capable of taking that. So this produces VGA compatible output. We've then also got a keyboard, PS2 keyboard controller here, and the keyboard is plugged in here. We haven't plugged in the mouse yet, that will be coming in future videos. We've got the floppy disk controller up here. So floppy disk controller is a single chip and a crystal oscillator there. Then we've got our floppy disk here. And then down the bottom, the more recent additions that we added a real-time clock down here with a backup battery, so the Breadboard PC can keep the time of day and the current date. And then we also, in the most recent videos, we've just added a hard disk controller. So this is actually adding a modern SATA hard disk via an IDE to SATA converter, and we've actually plugged that in. So that's the board. If you want to know more information about this, if you look in the links at the bottom of the video, there's links to the whole playlist, and the summary video summarises the first 36 videos building this out, so that's probably a good one to start with. So let's switch this on. I have a bench power supply providing 5 volts, and at the moment it's now at about 4.5 amps. So when the hard disk drive and the floppy disk drive are spinning, then it does use a bit more power. Now you'll see here when it starts up, it doesn't immediately start up into booting the BIOS and booting the operating system. It shows Nanocomp 8088, and this is the built-in monitor that was based on the one I used on the original 6809 Nanocomp project. And if we just have a look, what we're able to do here is inspect memory. So for example, we can go through memory, we can change the memory if we want, we can type in a start address, and we also did some extensions onto this to allow it to work with the 1 megabyte address space that the Intel 8088 has. So we're able to set some of the segment registers so we can actually run code in different areas of the memory. It also has a load and save function, so we're able to load programs from the serial port over the side here, and we can also save data to the serial port. And this allowed me to get the BIOS working properly until such time as it was able to go in. Now what I do now is we just type in B to boot the BIOS, and then it'll actually start up as if it were powering on. So a small tune to show that it's coming up, and we can see now that the BIOS is coming up here. I'll switch to full screen view so we can see it a bit better. You can see here that it's detected the hard disk drive, but because the floppy disk is actually loaded into the drive, it's actually booting off the floppy disk drive first. You can see it come up with today's date, and the time is also pretty accurate. So this has brought up MS-DOS 3.30, and the reason why we're using this version is about the earliest version of MS-DOS that knows about the high density 3.5-inch floppy disk drives. So that's the 1.44 megabyte floppy disks. Earlier versions did struggle a bit with formatting disks that would work cleanly using the 1.4 megabyte floppy disk drives. So we can see here on the A drive we've got the DOS files itself. We've got one of the very early text adventure games from Infocom, so that's Zork, and I've also got a couple of utilities, so Norton Utilities and the Norton Editor as well, which were very useful for early versions of DOS that didn't really come with very much in the way of editors and other utilities. So I'm just going to eject the floppy disk from the drive. So we're now going to reboot with floppy disk ejected, and it should now boot off the hard disk. You can see here that the BIOS is by Sergei Kiselev, the XI8088 project we've used quite a bit. Now this is the XTIDE Universal BIOS, which is software which allows modern hard disks to work on the legacy hardware such as the 8088. So we've now got the date, which is coming up correctly, and the time is accurate as well. So now we're actually running off the C drive, and we can see we've got our files there. This disk is actually formatted using the FAT12 file system, which means it would still theoretically work with MS-DOS 2.1, 2.10, PC-DOS 2.10. You can see here we've now got a number of things here. So what I'm going to do first of all is have a look at one of the first text-based adventure games, Zork. So just see if we can run this up. So you're standing in an open field west of a white house with a boarded front door. So we'll just do a few turns here. So we'll go north, north. You can see that there is a large tree, so we'll climb the tree. Climb the tree. The large egg, precious jewels, songbird. So take egg. We'll try and open the egg, which becomes important later, and then we'll just type verbose so we get more description. So now we go down, back in the forest path, we'll go south and south again. Zork is working. Perhaps might do a run through Zork at some point in time. It is possible to get through all of Zork in about 10 or 15 minutes if you know what you're doing. So just going to quit that. So one of the other things that I have been using in the earlier videos is the Norton Utilities. This in particular is very useful for looking at the low-level configuration of the system. If we just have a look at disk information, you can see that this is 16 megabyte disk. Although the sectors are 512 bytes, they're actually organized into clusters of 8 sectors. That means we allocate files in chunks of 4K, and we've got a total of 4001 clusters. Now, one of the things you can do with Norton is actually have a look at some of the low level information about the disk. So what I'm going to do first of all is to have a look at the master boot record. So this is actually on side 0, cylinder 0, sector 1. We'll look at one sector. This is where the disk drive partition information goes. So this is the way how when the BIOS boots up is actually able to run some code that then loads the operating system. So you can see here it's gone into the partition table editor to start with. So the partition table is in fact a region of bytes in this 512 byte sector. You can see there that we have DOS12, FAT12, which is bootable, and you can see we've got about 32,067 sectors, which is about 16 megabytes. So if you look at that in hex mode, you can see that we've actually got there some of the invalid partition table, error loading operating system, missing operating system, and down the bottom there where you see where the cursor is flashing, this is actually the partition table. So this area in here is where we can record information about up to 4 partitions, and if we had other partitions there then the rest of that would be populated. Then if we go from side 0 to side 1, what we can now see is this is the actual boot record. So you can see over on the right hand side here, this is an MS-DOS 3.3 boot record, and if we look at it in text mode, you can actually see there's a couple of the error messages: non-system disk or disk error, replace and strike key when ready, disk boot failure, and you can also see there's the 2 files, io.sys and ms-dos.sys, that this boot sector looks for to establish if there's a valid MS-DOS operating system on here. So in some future videos I'm going to go into some of the details of how exactly the PC starts up and how MS-DOS boots, but for the moment what we're just going to do is to go back and have a quick look at the directory information, and then we'll end the video. So if we look at the root directory, we can see here that this is showing the root directory where we've got io.sys and ms-dos.sys, and we can also see that those are archived read-only, system hidden over on the right hand side there. Now under normal circumstances, under MS-DOS 3.3 you won't actually be able to see these files in any directory listing. Later versions of MS-DOS you can actually look at hidden files, but this version is fairly limited on what you can do. And you can see then that we've got the various folders and things for Zork and the other things on here. And finally there was some of the tools I've got here. There's one in particular that helps to test the video card. So we have a monochrome display adapter video card. So if we do CT test 7 for mode 7, this just shows the monochrome display adapter fonts or the characters which are available, and also then shows the different attributes that can be shown on the screen. So we can see there's normal and bright text, underlined text, and also reverse and blinking. So one other thing before we wrap up, I just wanted to mention, you'll see that around the board here we've actually got little meters. There's actually little voltmeters around the board, and this just helps to ensure that we've got the right voltage the various bits of the board. One of the problems with building large projects like this is that you can run into power distribution problems, and there is actually a big power distribution block up here. So I've got wires going to specific areas of the board to make sure that the power's okay. So I'm going to stop the video there. So what I've shown is that we've been able to build a PCXT compatible breadboard PC on solderless breadboards. We've managed to actually get it to boot MS-DOS 3.30 off both floppy disk and off the hard disk there. If you want to know more about this, then there is a link at the end of the video here for a summary that summarises the first 36 videos in this series, and there's also a playlist where you can go through every single video in the series if you should want to. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you found the content interesting, please hit like. It just helps to make the videos available to more people. Thanks for watching.